Hey class, happy Friday. This is week 6 of remote learning here. Today we're just going to kind of review all the lessons that we learned this week, all right? So this is going to be solving quadratics review 1 here. And then after this little short review, you guys will just practice using the quizzes to kind of recap everything that we've done this week, all right? So for these first two problems here, we're going to solve these equations using that zero product property, right? Be sure to circle your solutions and remember to write out two equations and setting each product equal to 0, all right, and solving both. All right, so example 1, we have x minus 5 times x plus 4 is equal to 0, right? So this is my apples and orange again, right? So this is my apple here. So my x minus 5, I'm going to set that equal to 0 and solve, right? And to solve this one, we add 5 to both sides, and we get x is equal to 5. All right, and then my orange equation on this side, right, or my orange is x plus 4. So I'm going to set that equal to 0 and solve that as well. So we subtract 4, and we get x is equal to negative 4. So those are my two solutions. All right, example 2 is very similar to this, right? In example 2, we have x plus 7 times 3x minus 2 is equal to 0. All right, so I'm going to set, again, my first product equal to 0. All right, so I can see that x plus 7 equals 0. And to solve this one, right, we subtract 7 from both sides, right, using inverse operations. And we say that x is equal to negative 7. All right, and I'm going to do the same thing to my second product here. Right, 3x minus 2 is also equal to 0, right? Because that zero product property tells me I can do this, right? Because one of these products has to equal 0. All right, so to solve this one, we're going to add 2 first to both sides. Now we say that 3x is equal to 2. And now we divide by 3, right? And if your fraction does not reduce, right, just leave it as 2 over 3. All right, so those are my two solutions for number 2. All right, so in these first two examples, right, the problem was already factored for us, and we just had to set up our two equations and solve. All right, my next two examples is what we learned yesterday, right? So we're going to have to factor these first by finding the GCF and then solving them. All right, so these two are going to take a little bit longer, a couple more steps involved. All right, but this is all stuff that we've done before, right? All these skills we've done before. All right, so for 3 and 4, right, we're going to solve these by factoring using that and then using that zero product property. All right, and for both of these, we're going to use that factoring using that GCF, or the greatest common factor. All right, so that means for 6x squared, right, my factors are x and x, 1 times 6, and 2 times 3. And for my 18x, right, my factors are x, 1 times 18, 2 times 9, and 3 times 6, right? And if we don't remember all these factors, that's okay, right? We have this factors chart, all right? So hopefully you printed this out and have this handy, right? Because we needed it yesterday, we needed it Tuesday, all right? This document is great, and we're going to need it next week and the following week as well, all right? So this factors chart here is what you should also have in front of you when you're taking the notes, when you're doing the homework, or taking the quizzes. All right, because this chart here will kind of list out all the different factors. Right? We can see we have 1 and 18, 2 and 9, and 3 and 6. All right, so after we list out all the factors, right, now we want to circle, right, find the greatest common factor. All right, so I'm going to look at my numbers, and I see my greatest common factor of my numbers is going to be this 6. And now I'm looking at my letters. They both have an x in common, right? Both of my terms have an x in common, and a 6 is the greatest number in common. So therefore, my GCF is 6x. All right, now once I found my GCF, right now I have to pull that out, all right, and I have to put back whatever's left over into my parentheses, right? Because again, factoring means breaking things apart, all right? So for my 6x squared, if I break it apart and I pull out this 6x, right, I'm left with, well, 6 times 1 is 6, and then I have this extra x. So my x is just going to go back here, right? I could put 1x, but I don't need to because it's just an x. All right, and now for my 18x, well, 6 times 3 gives me 18. Right, and I used up this x as part of my GCF, so I just have that 3 to put back here. All right, and now that I broke this apart, right, I took my 6x squared plus 18x, and I broke it up into 6x times x plus 3. And now I can solve both of these equations. Right? So now I can say that 6x is equal to 0. So I would divide by 6, divide by 6. Well, 0 divided by 6 is 0. So that's my one solution. And now I take my second product here of x plus 3, set that equal to 0, and solve. All right, and we solve using inverse operations. So in this case, I'm going to subtract 3 from both sides, and we get x is equal to negative 3. So those are my two solutions for example number 3. All right, so why don't we pause the video, and you guys work out example number 4. All right, work it all the way through, list out the factors, factor it, solve it. All right, and then write down your two solutions for me. All right, let's see how we did here. All right, so for 4x squared, right, it's x and x, 1 times 4, and 2 times 2. Right, those are my factors of 4x squared. And now my factors of 20x are x, 1 times 20, 2 times 10, and 4 times 5. Awesome. All right. So now we want to find our GCF, right? Our greatest common factor. Well, let's see. I see a 4. Looks like a number. It's going to be my greatest number in common is going to be a 4. And now I see that they both have an x. So therefore, my GCF is 4x. All right, so now to break this apart, right, I'm taking my 4x squared plus 20x, and I'm going to break it up into pieces or factors that multiply, right? So I have this 4x already. So now I have to get back to 4x squared. Well, 4 times 1 is 4, but I have this x. So right, it's just 1x, or really, right, just x. We don't need to write that 1 there. All right, and then if I take out this 4x out of 20x, well, 4 times 5 is 20, and I don't have that x, so I'm just going to put this 4 back here. All right, so that means that 4x squared plus 20x broken apart or factored gives us 4x times x plus 4. All right, so now that I factored it, now I can set each one of my products equal to 0 and solve. All right, so 4x equals 0. I would divide by 4. And I get x is equal to 0, right? Because 0 divided by 4 is 0. And then I take x plus 4. I set that equal to 0 as well. I subtract 4. And we get x is equal to negative 4. So those are my two solutions. And hopefully you have you got the same answers, or hopefully very, very close to that. All right, we just got 2 more to do here. All right, so these last 2 are trinomials, right? Are 3-termed polynomials here, right? So for these, right, we have to find the factors of our last term that add to the middle term. All right, so we're going to find factors of 20, right, or numbers that multiply to 20, but that add to a positive 9. All right, so here, right, we're going to list out all the factors of 20. All right, again, this goes back to my factors chart here. If I don't know my factors of 20, right? So down here at the bottom, we have 1 and 20, 2 and 10, and 4 and 5. All right, 1 and 20, 2 and 10, and 4 and 5. Right, so after I list out my factors, I'm seeing which one of these pairs is going to add to a positive 9. Well, that's going to be 4 plus 5 is going to give me that 9. All right, so that means Now I can finish factoring this, right? I'm going to break up this trinomial into x plus 4, x plus 4 times x plus 5. Right, so when we factor a trinomial, my result is two binomials. All right, so now that I factored it, now I have to solve it, right? So we're still not done yet because we have to set each one of our products equal to 0. All right, so then we get x is equal to -4. And now we have to solve our other product here, right? We say x plus 5 is equal to 0. We subtract 5, we subtract 5, and we get x is equal to -5. So those are my two solutions for example number 5. All right, I want you guys, again, pause the video, and I want you guys to try number 6 here on your own. All right, work it all the way through, just like I did on example 5, and write down your two solutions for me. All right, let's see how we did here. All right, so here we're finding factors of 32, right? Or numbers that multiply to 32 that add to a positive 18. All right, and again, if you were not able to print these out, right, you can just make a simple t-chart like this, right? And right multiplies to 32, it adds to 18. All right, so now I got to list out my factors of 32. All right, so again, if you need to, reference this chart. All right, and here are my factors of 32. 1 and 32, 2 and 16, and 4 and 8. So we got 1 and 32, 2 and 16, and 4 times 8. All right, so after we list out those factors, now we're looking for the pair that's going to add up to 18. Well, after you list these out, right, it's just going to be this 2 and 16, right, because 2 plus 16 gives me my 18. All right, so that is my factored pair that I'm going to use now to finish factoring this problem. All right, so again, this is going to be two binomials here, x plus 2 times x plus 16. All right, so hopefully you're able to factor it like that. All right, now we actually have to solve it, right? Do this extra last step here of saying that x plus 2 is equal to 0. So we subtract 2 to both sides, and we get x is equal to -2 is my one solution. And then I also am going to do that x plus 16 is equal to 0, and I subtract 16 from both sides. And I can say that x is equal to -16. All right, so again, hopefully you had those solutions or got something really, really close to that. All right, awesome. Nice job. Way to finish up the week on a positive note here. All right, and go ahead and work on that quizzes, right? Just take care of it today, get it over with, so this way you can enjoy this weekend, and we'll get back to some more math on Tuesday.